Dear students, topic of the presentation is occurrence of noble gases, separation by charcoal adsorption method. I am Dr. Digna Varghese, Assistant Professor, PG in Research Department of Chemistry, Christ College Autonomous. Occurrence of noble gases. Group 18 elements occur in the universe in the free state except radon. They are present in stars and Earth's atmosphere. Radon is naturally occurring as radioactive element. Radon is obtained by the radioactive decay of uranium ores and alpha decay of radium. Rarest elements in noble gases is xenon, and xenon and radon are present in natural gas and in radioactive minerals in the occluded form. Occlusion is nothing but the adsorption of gases on the surface of metal. Helium on Earth comes from the alpha decay of heavy elements such as uranium and thorium found in the Earth's crust, and tends to accumulate in natural gas deposits. That is the alpha decay of uranium giving helium. Abundance. The atmosphere abundance of noble gases in dry air is 1%. Helium is the second most abundant element in the universe and is a major component of stars. Helium present in atmosphere in traces of about 0.00524%. Therefore, it is only the third most abundant noble gas in the atmosphere. Why this so? Because helium thought to have arisen as byproducts of the decay of radioactive elements in the Earth's crust. Because of its low mass, helium escapes from the Earth's atmosphere into outer space. Helium also present in natural gas to extent of 2 to 7%. Natural gas is naturally occurring hydrocarbon mixture, and it contains methane, higher alkanes, carbon dioxide, nitrogen, hydrogen sulfide, and helium. The abundance of noble gas in dry air near sea level is noble gas such as argon. Its content about is 9.3 into 10 raised to minus 3, and for neon it's about 1.8 into 10 raised to minus 5, and for helium 5.2 into 10 raised to minus 6, and krypton 1.1 into 10 raised to minus 6, and for xenon 8.7 into 10 raised to minus 8. Among them, argon is the most abundant noble gas and xenon is the least abundant gas. The abundance of argon is increased as a result of the beta decay of potassium 40 to form argon 40, which is the most abundant isotope of argon on Earth. Beta decay of potassium is shown here, in which after beta decay the atomic number decreased by 1 unit and mass number remains the same. Argon being relatively rare in solar system. Xenon has an unexpectedly low abundance in the atmosphere. Radon is formed in the lithosphere by the alpha decay of radium. Here the alpha decay of radium is shown. The atomic number decreased by 2 units to converted into radon, and mass number decreased by 4 units. Sources of noble gases. Helium. The principal source is natural gas well, and for neon, argon, krypton and xenon, the principal source is the fractional distillation of liquid air. And for radon, that is from the uranium mineral. Separation or isolation by charcoal adsorption method. Noble gases are isolated from the atmosphere. Isolation methods. There are two methods involving isolation of noble gases. First one is isolation of noble gas mixture from dry air. Second one is separation of the components of the noble gas mixture. And isolation of the noble gas mixture from dry air is a chemical method. This method happens only by the use of chemicals. And the separation of the noble gas components from the mixture is done by a physical method. There is only differing the temperature of the system. Step 1. Isolation of noble gas mixture from dry air. The apparatus consists of a 50 liters capacity round bottom flask. The round bottom flask is fitted with two heavy platinum electrodes, and there is gas inlet tubes. The two inlet tubes are here. One is for carbon dioxide free air, oxygen mixture is passed into the RB flask, and other inlet tube is used for sodium hydroxide solution. And the third one is an outlet tube that is used for the used NaOH solution. Rayleigh-Ramsay chemical method is explained in this slide. That is, there is a round bottom flask. Inside the flask, by the use of an inlet tube, we passed carbon dioxide free dry air and dry oxygen in the ratio 9:1 by volume is introduced into the flask, and applying there is an electrodes, platinum, two heavy platinum electrodes, which is to this an electric discharge is passed 6000 to 8000 volt, and all the nitrogen and oxygen present in the air combines to form nitrogen oxides, nitric oxide and nitrogen dioxide. A continuous stream of sodium hydroxide solution is introduced into the flask to absorb nitrogen oxides. Nitrogen dioxide reacts with the sodium hydroxide to give sodium nitrite and water. There is an outlet tube to the used sodium hydroxide solution is taken out through this outlet tube. The residual gas in the flask is now a mixture of noble gases and a trace amount of oxygen. All the nitrogen and oxygen combined with the nitrogen combine to form nitrogen oxides, that is by applying sodium hydroxide solution and removing the nitrogen oxides. Remaining unused and used sodium hydroxide is taken out from the flask by an outlet tube, and in this flask there is only excess oxygen or unreacted oxygen and a mixture of noble gases. This mixture is passed through alkaline pyrogallol. This is a trihydroxy derivative of benzene. It is a white color solid. It is water soluble solid, although the samples are typically brownish because of its sensitivity toward oxygen. Pyrogallol is a white solid, and when it is absorbed reacts with the oxygen, forming brownish color. It absorbs oxygen. Pyrogallol absorbs from the mixture of noble gases and oxygen from the RB and converted into pure noble gases in the RB. Therefore, by the Ramsay and Rayleigh chemical method, we can isolate the noble gases. Step 2. Separation of the components of the noble gas mixture. In this, Dewas method or charcoal adsorption method is used. It's a physical method. Separation of the noble gases by means of their adsorption on charcoal at different temperatures. Advantage: the differential selectivity of the charcoal for different noble gases. But in this case, there is helium which is not adsorbed on charcoal in this process. This figure shows the Dewas flask or a double-walled bulb. Inside this there is a coconut charcoal, and the coconut charcoal is surrounded by a cold bath, and this all setup is known as Dewas flask. Therefore, it is known as Dewas method, or another name is charcoal adsorption method, and it is a physical method because there is only change in temperatures. Flow diagram for separation of the noble gases, that is Dewas charcoal adsorption method, is explained through a flow chart. First, the mixture of noble gases isolated from by the chemical method. It contains helium, neon, argon, krypton and xenon, which is kept at a charcoal which is brought in contact with the first coconut charcoal at a minus 100 degrees Celsius. Argon, krypton. In this, krypton and xenon are adsorbed by the charcoal, but there is unadsorbed helium and neon. We know adsorption is a surface phenomena only by means of a weak van der Waals force of interaction between the charcoal surface and the gases. Here the unadsorbed helium neon, which is brought in contact with the second coconut charcoal, or it is pumped out and introduced into the another Dewas flask containing coconut charcoal at a minus 180 degrees Celsius. In this case, the helium is unadsorbed state and helium is collected. We can collect helium here. Once again, I am explaining that mixture of noble gases obtained by the chemical isolation method, which is in contact with the coconut charcoal at minus 100 degrees Celsius. Here, two noble gases, helium and neon, in the unadsorbed state, which is in pumped into the another Dewar flask containing coconut charcoal at minus 180 degrees Celsius. In this case, helium unadsorbed, and we can collect helium. And in the second charcoal at minus 180 degrees Celsius, here helium is in the adsorbed state and it is warm to 0 degree Celsius. Temperature is increasing to 0 degree Celsius and helium diffuses out. Diffusion of the neon diffuses out from the charcoal, and we can collect neon here. First charcoal is at minus 100 degrees Celsius. Here we get the unadsorbed state helium and neon, but argon, krypton, xenon is on the adsorbed state in this charcoal at this temperature condition. In this case, argon diffuses when it is contact with the third charcoal, coconut charcoal, at minus 180 degrees Celsius. Third charcoal at minus 180 degrees Celsius, argon in the adsorbed state, and it is the temperature of the charcoal increased into 0 degrees Celsius and argon diffuses from the adsorbed state and argon can be collected. In the case of first coconut charcoal at minus 100 degrees Celsius, krypton and xenon is there at a adsorbed state, and this is warm to minus 90 degrees Celsius, or it is warm to higher temperature. Krypton diffuses out and krypton can be collected. First charcoal at a minus 90 degrees Celsius, xenon is in the adsorbed state. It is warm to 0 degrees Celsius and we can diffusion of xenon takes place and we can collect the xenon here. Thank you.